I got this gig being a art teacher because I'd done puppetry before, and I realized since I was teaching art, I should probably try and be an artist, and which is the wrong way to do it, but it worked. And I did this thing where I got obsessed with drawing, and I would go to basically in any town, at pretty much any night of the week, you can go someplace and draw someone who's naked. And so I did this most nights. And one of the things that I was basically obsessed with this was called blind contour drawing. And it's where, and the way it works is you look at someone, and first you look at the page, and you put your pen down, and then you look at someone, and you wait until you believe that your pen is actually touching the top left part of their head. You wait for this, and it happens. And then you begin to move your eye down the left-hand side of their head, and the idea is you coordinate your hand so it makes the same kind of motion, but at a smaller scale, because your paper is not as big as a person. And, well, maybe it is, but in this case, it wasn't. And there's this thing that happens because you're paying attention to the world and you're moving. And it's one of those things where it's the same exact exercise he mentioned, which was start a line and go on. And in many ways, I feel like there's a metaphor here for as long as you're moving forward with intention and a sense of just and intention, I think, is all it takes. You're engaged with life and something's happening. And I got kind of addicted to this feeling, which is why I would go out every night. And I would wait till I felt like I was actually touching the person's head, which is kind of weird. And then I would move the pencil and move the pen and connect. And what ended up happening is I ended up basically just becoming immune to most art. Because what I would see when I saw art was, did this person have intention? Was this person engaged with their subject? Were they connected to the art as they were making it? And it meant like my art taste went from like liking half of everything I saw to liking like 1% of everything I saw. Because when you see authenticity, you know it. Once you've experienced authenticity and in whatever genre of whatever it is you do, you know it and you can go after it. And so when I felt authenticity of line, whenever I saw art, I'd go like, does that have authenticity of line? And I would just know if it did or not. And then if it did, I would like it. So there's something really powerful there that I just want to, about lines and drawing them and going forward. I started a company called MakerBot, and we're having a great time. We started, these are my friends. I moved to New York in January of 2007, and by the end of the year, I'd formed a thing called NYC Resistor, which is a clubhouse for hardware nerds. And we share a workshop, a clubhouse, and we fill it with all of our tools. We took all the tools out of our closet, and we brought them in to a clubhouse. And then we bought more, because we could collectively buy laser cutters and stuff. And because we couldn't afford a MakerBot, or afford a 3D printer, we had to make a 3D printer. And when it worked, we thought everybody should have one of these, and we started a company. This is my friend Raphael laughing maniacally because he's operating our cocktail robot. And pro tip, never put a random button on a cocktail robot. So there's, one of the things that I'm going to kind of rush through this because I want to really hit this theme of manifestation. The thing that a MakerBot does when you have one is it turns you into somebody who can manifest anything. And this is a superpower. And it turns people who feel like they aren't creative into creative people. It turns people who feel like they couldn't change a tire into people who become experts on creating prosthetics for kids. It transforms people's lives because it's a tool, and we get the same kind of feedback that we got when computers started. When we started, people were like, nobody will ever want one of these. This is why I go to the store, because I don't need one of these, people would tell us. And it was the same kind of tone that people used when they were like, I don't need a computer, I have a pocket calculator. So we knew we were on the right track. This is the MakerBot Replicator 2. This is our flagship product. It's the most elegant 3D printer you can get. It sits on your desktop. It's our 4th generation machine. It makes things of very high quality, high resolution, and you can make things about the same size as a loaf of bread or like a size 8 shoebox. We make these in Brooklyn, and we actually explored the possibility of making these things in Asia, and what we found was that basically our product, which is an electromechanical device, needed skilled labor. And basically skilled labor is almost the same price anywhere you go in the world. And the thing that you can get, like you said, if you want to go manufacture in China, in theory, is you get very cheap, unskilled labor that requires a lot of infrastructure and work to actually do the work, because it actually takes people who care about your product to make 2 holes line up and put a screw through them. And that sounds trivial, but if somebody doesn't have the intention that they actually care about something, it just ends up a piece of crap. We also found that all the factories we visited in Asia were going out of business and buying factories in Malaysia, that they were way more interested in making products for the emerging billion people who are about to become middle class in China, and that it was going to cost $50 to ship a MakerBot from China to Brooklyn, and then we would ship it out again. When you think about that and you think about how many hours are in the amount of, just in the shipping cost alone, if we can make a machine, for less than, or that takes an assembly cost of less than $50, we're good. And so we actually have a 55,000 square foot, soon to be 100,000 square foot manufacturing facility in Sunset Park neighborhood. It's totally badass. And we're pioneering this idea that you can make it here again. I mean, Detroit destroyed manufacturing. For whatever reason, the infrastructure and system that was put up just got disrupted and just wrecked. It did not work. And the latest thing that came out of there that was any version of a success was the Humvee, and by all accounts, that's basically its own disaster. So it just took too long, cost too much, and actually doesn't do what it says it's going to do, which is protect people. So, mind you, I still want one because they're big and have big tires, but that's how those things work. Anyhow, side note. It's really you're going to see happening as more and more companies start to move manufacturing back to the US, is you're going to see that they build products faster. It's a very competitive world right now. We can have an idea for a product and bring it to market in less than 6 months, which if you've done products, you're like, that's impossible, and it is impossible, and we do it anyway. But it's only possible because our engineers work really product engineers work really tight with our manufacturing engineers. So the manufacturing engineers come over and say, you're not putting any screws on the bottom of this. I'm not turning this thing over on the assembly line. And they're like, oh, well, then there's no screws on the bottom. We'll figure that out and get back to you. And they work closely together so that we can actually get this thing done quickly. This is Casey Hulgren. She's here in New York. She's a MakerBot operator and a pioneer. She got MakerBots because she's a set designer, and her sets are on Broadway. She's a total badass. And she used to make things with cardboard and glue and X-Acto knives and blood, and now she designs these things on her computer, runs MakerBots in her closet because she lives in a studio overnight, and then takes them into and to argue with the directors the next day. And because of this, she makes these beautiful sets, and she's become an entrepreneur because she's repurposing all the digital designs that she's doing. If you have a MakerBot, you can actually make all her designs for free because she puts them on our site Thingiverse where you can download them. Or if you're a dollhouse obsessive, you can go to prettysmallthings.com and buy her furniture from her that she's made as dollhouse furniture. And it turns out, in the dollhouse world, which there is a dollhouse world, there's only so many types of furniture, because in the old way of manufacturing, you have to make 10,000 of anything and justify that and know that there's a market for 10,000 of those things. And so the furniture is boring. There's no mid-century modern furniture in the dollhouse world, and if there is, it's ultra custom and really expensive. Now you can go on Pretty Small Things and get Windsor chairs, and all these absurdly cool, if you're a furniture nerd as well, you can get all these furniture things. Like it turns out my partner's mother, for whatever reason, collects small chairs. It's just, she's one of those. There are those people too. Like that's one of the beautiful things of this world is there are those people, whatever it is. And so I made her a bunch of these, and she's really happy. Anyway, moving right along. Ryan Kane we're seeing these used in schools. I'm actually working on a school initiative to put a MakerBot. Don't tweet this because I haven't announced it yet, but I'm going to put a MakerBot in every school in the United States, and that's actually not enough, but we have to start somewhere. Ryan Kane, his students make little houses that are very personal, and then he puts them all along a miniature river and then they put a hose down it, and then they turn on really hard, and you see the effects of erosion as their houses all wash away. Powerful teaching. This is ComTom's daughter, and she is a happy girl because she just got back from an amusement park. She's 41.5 inches tall. She wouldn't have been happy if her dad hadn't had been had that superpower of being a MakerBot operator and made the inserts for her shoe that make her a half-inch taller. This is the power of a MakerBot operator. Power to make the things you need and make your daughter happy. I mean, that's a face you want to look into every day. It's interesting. Once we came out with the MakerBot Replicator 2, it's black. It looks more professional than our previous wood prototypes. They were products and prototypes. We started to get them into places like NASA and Lockheed Martin. We actually just launched this video. And this is John Camp, who runs the Advanced Manufacturing Institute, I think is what it's called. And he basically told me that they used a MakerBot on the Webb Space Telescope, which is the next generation space telescope after the Hubble. And it saved him 6 months and $1 million with just one machine. And what they did was, it's interesting. So space nerds, you're going to enjoy this. Everybody else, bear with me. So the way it works is there's actually 2 telescopes, so it's redundant. When you're in space, you want to be redundant, so if one breaks, you have another one. And they realized after they had made them, and the machines were in a cryogenic chamber, which is where they freeze it and get it down to as close to 0 Kelvin as they can, and take all the air out of it to mimic space. They leave it in there for a long time, and then they shake it and see if anything breaks. While it was in there for an extended period of time, they realized that the tolerance stack-up was such that cosmic rays could come into the telescope and miss some critical filters and hit the sensor when it shouldn't hit the sensor and then ruin the sensor. And they realized that this wasn't just something that could happen, it would probably happen. And so they actually built a model of the part of the telescope where the rays come through. And then they built a model of all the parts they were going to have to make, baffles in there to make it so that the light didn't hit. And then they made models of all the tools that they were going to have to make it work. And then they practiced. And it was about a 20, 30-minute operation, I believe you said. And they practiced it for 2 months. And it required one of these little snake video things because it was basically doing something blind down a tube deep. And after they'd practiced for a while, they built all the tools, they knew all the problems. When they came out of the cryogenic chamber, they had all the parts that they'd fabricated after they'd tested them and found that just made it perfect. And they built all the tools, actually put the parts in, and then they put it in, and 15 minutes later it worked. It was one of those things where if you'd done it the old way, you would have had to wait for it to come out of the cryogenic chamber and then build all the stuff and test it, and then hopefully not break the super expensive space apparatus. I love it. Go watch this video, it's great. Space, makes me happy. I met the JPL guy. JPL's Jet Propulsion Laboratories, they're part of NASA. CTO comes up to me at CES and is like, we use MakerBots all the time. We used to, anytime basically an engineer needs to make a prototype that's going to cost more than $2,000, we just buy them a MakerBot and put it on their desk. And I was like, yes. And then he's like, you're going to have to come by and see this sometime. I know you're busy, but you should really make time. And I'm like, come visit Jet Propulsion Laboratories. yeah, we're going to do that. So I'm looking forward to that. We just launched the MakerBot Digitizer. This is actually a prototype. The way we make stuff is we try things out. And there's kind of 2 ways to do engineering. We do kind of a mix now. Originally, we started the company. None of us were engineers. But we had this intention that we wanted it. And we weren't going to stop. And that is a very powerful force in the universe. If you want something and you're not going to stop, and it's a good intention, and you have a positive attitude, like the world lines up to just make it happen. Like obstacles disappear or pathways get made through them. People show up to help you. Things start to become magic when you have this kind of intention. And we kind of joke, like if we were engineers at the beginning, we'd still be working on the prototype, and it's probably true. We just built a prototype, and when it didn't work, we built another one, and we tried to make it a little bit better than the last one. And this kind of iteration is one of the most powerful things you actually get when you get a MakerBot, because you can iterate fast. We iterated quickly. We probably made 15, 20 different prototypes. When the last prototype worked, luckily it was like 15 minutes before I'd get on a plane and launch the company. It was good, and it still works, which is good. So the other way is you plan it out and you come up with all your kind of what you want it to look like, what kind of tolerances you want to have, all these, you make up all these kind of like things that you want it to exist, and then you try and build that. When you engineer that, you usually end up using when you do it that way, when you're broken, you do it in an iterative way. You usually make the minimum kind of thing because you can't afford to make it anymore, and if you need to, maybe you'll spend a little bit more on something, and then you'll see if that works. And if that doesn't, you'll incrementally make it more expensive. When you start out with all the expectations of what it's going to be, you overshoot it and you make something way more expensive. So now we kind of mix those two because we plan what we're going to do because we have enough experience that we have some idea of where we want to land. And then we iterate quickly to get there. So we made this desktop 3D scanner, the MakerBot Digitizer. And we use 3D printing and iteration to make it. And it quickly turns the things in your life into digital designs, which is, the MakerBot replicator takes digital designs and turns them into physical objects. The MakerBot Digitizer takes physical objects and turns it into digital designs. I cannot wait till your grandparents get one of these and digitize every little tchotchke in their house for the benefit of humanity. Well, and engineers will use it too, but I'm actually kind of interested in all the things that are precious to you that are smaller than 8 inches in diameter and smaller than 8 inches tall. In my life, about 5 or 6 years ago, my dad asked me, like, what would you like? I'm writing my will. What do you want? And I'm like, I want that little bronze Buddha that you got before I was born and that's been in the family since forever. And he was like, well, you don't have to wait for that. Here, you can have it. Here's a gift. And I promptly, once we got the MakerBot Digitizer, I promptly scanned it, made a copy, sent it to him. So now he's got sort of a special keepsake from the gift. And I'm going to send one to my brother, too, eventually. So this idea that you can scan things, and then you can make copies of them. You can modify them. You can add hat. I like more beard, just anything, more beard. And then we have this website, Thingiverse, where people share things. We actually developed our community unintentionally before we launched MakerBot. We created Thingiverse. Thingiverse is a place where people share digital designs to make anything. And when we started, we spent the first year or two, really it was just us uploading stuff. We had a laser cutter and then a 3D printer, and we were uploading a couple things. And after a year or two, sometimes you have to do things for like 2 years with nobody else doing them. Just because, because you have to, or whatever reason. And then now, whereas there was probably like less than 100 things uploaded in the first year, yesterday 500 things were uploaded. So that's 500 things yesterday that you can make today that you couldn't make the day before yesterday. And it's filled with both just some absurd things and some practical things and some magical things. So, like there's a little circle there. That's actually a 3D printable bearing. It's not a ball bearing, but it's got a cross-hatched geared pattern so that it doesn't move horizontally. And it's a working ball bearing that you print, and you just take it off, and it works. It's really cool. And, everybody if you get a lemon and you don't have a lemon reamer thinger, you can just print one, probably faster than you can go to the store. It's that kind of stuff too. And then there's just cute things and wonderful things and things. It's a universe of things. So, we've set up the digitizer so it automatically shares if you check that box. It makes beautiful objects. I'm running out of time. Oh, cats. So this idea of starting with an idea, so one of the things I wanted to get to, and I've got 20 seconds, I'm going to probably steal another 20, is this idea of starting, and then just keeping going. We're on an adventure at MakerBot. We know what direction we're going in, but we don't know what's going to happen. And I think that's good criteria for pretty much doing anything in life. Going forward because you want something to exist, not knowing exactly how it's going to happen, but being willing to push through any obstacles and enjoy the experiences you get there. So I'll end on that note. Thank you.